Good morning. John Gilkison Aero Stealth here. It is Monday, March 21st, 2023, and I wanted to shoot a short video this morning on a demonstration I've rigged up. I've done stuff on carbon dioxide before. One of the things I did was draw a cube which was 10 by 10 by 10, which is 1,000 cubic units. And then you just take one of those little cubes out of that thing, and 1/3 of that is the concentration, or 4/10 of that is the concentration of CO2 in the atmosphere. And it shows you what this concentration is relative to the total atmospheric gases, which is interesting, but it's almost enough to belay some people's fears. But it's a counterintuitive thing about how little carbon dioxide it takes to warm the planet. But you can kind of think of carbon dioxide maybe as a space blanket over the planet, huh? Really thin and light. But every time you burn a gallon of gasoline, that gallon of gasoline, which weighs about 6.3 pounds, I believe, is translated into 19.7 pounds of carbon dioxide. And a lot of people are confused by this. How can 6 pounds of gasoline create over 19 pounds of CO2? Well, what they don't understand or seem to have trouble grasping is that it pulls 2 oxygen molecules out of the atmosphere to combine with one of the carbons in the gasoline, and that's what produces CO2. So 19.7 pounds of carbon dioxide is produced out your tailpipe every time you burn 1 gallon. So I was wondering, every year we put our pellet stove up, and I have to take the unused pellets out and rebag them or whatever. And I happen to have these jars here. This was a large jar, right here, which held pretzels. And this is a smaller jar that holds a product called pub mix, which is pretzels and other things. And it took both of them to get enough pellets in it to equal 19.7 pounds. Now what I was thinking was, if, let's say in the fall, we have another electric vehicle car show, is I want to bring this with some suitable large printouts to explain what it is. And the idea behind this is it's a visual metaphor for carbon dioxide produced by a gallon of gas. And the thing of it is, you can lift it. You can get a feel for what 19.7 pounds feels like. Not only that, of course I could get 19.7 pounds in a small piece of steel, for example. A 20-pound barbell, for example, would be enough to do that. But this gives it a little more volume, which gives it some heft. So here I am, I'm holding one of them. And this only made about 15 pounds, so I have to put another one on there. So here it is, I'm holding 19.7 pounds of the visual equivalent of carbon dioxide put into the atmosphere by 1 gallon of gas being burned. Now, quickly here, of course, this is my gas truck, fittingly enough, which we've been using a little bit recently, and it is using 7.16 times the amount of energy as this electric car uses per mile. And one of the things about the electric car, which I like to point out to people, is that the gallon equivalent of electricity only weighs 1 75 thousandths of a gram in that car. So that's nothing to transmit over the power lines. Whereas, of course, a gallon of gasoline for this vehicle here weighs 6.3 pounds. Now, as liquids go, like water, which weighs over 8 pounds, gasoline is a light liquid. And the first bath escape to go down to the bottom of the Marianas Trench in the early 1960s used gasoline in the bathysphere itself as a fluid which was lighter than water to help it come back to the surface. Kind of a fail-safe thing. As you could imagine, if they had any kind of gas in that bathysphere, of course it would be crushed at those depths. But liquids being incompressible, or only mildly compressible, was the obvious choice, and they needed a liquid lighter than water. So they used gasoline, which is an interesting safety issue, but they did nonetheless. So this is my short video for today. If you got any comments on how to elaborate further on this visual metaphor for CO2 to the atmosphere, I'd be interested in it. One of the things that I did figure out was that if you just took ordinary air, to get 19.7 pounds of ordinary air, you need a cube that's almost 2 meters by 2 meters by 2 meters. It turns out to be 1.9 something meters. It's like 63 inches on a side. So anyway, or is it 73? I forget. But once I work that math out, I'm going to get it written down. Maybe I can memorize it better. And we can put that with the display also. So I'll let you go. We'll see you down the road, everybody. And these electric cars can get you away from using this gasoline. It's reduced our gasoline consumption because we only drive this truck as needed. And we're basically driving it to keep it alive. So, you all take care, everybody. We'll let you go. We'll see you on down the road. Bye-bye.